Okay, definition. We say W is a linear transformation of U if W is equal to AU plus B, where W and U are variable, A and B are constants. And sometimes people call this is what? Multiplier. And B is what? Displacement. Okay. Now this is called linear transformation. Let me give you a very simple, easy example. Say U, the U list, consists of three numbers. 1, 2, 3. This is U1, U2, and U3. Okay? And the linear transformation of U, say W. How you obtain W from U? W is what? 2U plus 3. Okay? For example, U1 is 1. 1 times 2 is 2. 2 plus 3 is 5. So this is 5. This is W1. 2 times 2 is 4. 4 plus 3 is 7. So this is W2. And 3 times 2 is 6. 6 plus 3 is 9. This is W3. So we convert from U to W. And W is called a linear transformation of U. Okay? And A is the multiplier. B is what? The displacement. Okay? And after we make the linear transformation, look at the original one, list. The average U. The center of U distribution is 2. And the center of the new list, average W. How the new center related to the old center, okay? After we make a linear transformation. Well, how 7 related to 2? Well, you plug in the same linear transformation, right? 2 times U, 2 times 2 plus 3 give me 7. So property 1. Average W. How you get average W from average U? It follows the same linear transformation, right? The same linear transformation in our example, okay? So property A says linear transformation transfer from the old center to the new center. Follow the same linear transformation, okay? Now, second property, standard deviation W, the spread of the new list, how that related to the spread of the old list. So let's look at this example again, okay? Let's look at this example again. This is a center. What do you know about the standard deviation? Standard deviation try to measure the average distance to the center. So look at this 3. How far is away from the center? The distance is 1, okay? How far 1 away from the center? The distance is also 1. But after you make a linear transformation, this is a new center, right? How 9 related to the new center? The distance is 2. And how 5 related to the new center? The distance is also 2, okay? As you can see, from 1 changes to 2, from 1 changes to 2. So average distance to the center has been doubled. Why it has been doubled? Because you times 2, okay? Because you times 2. That's the reason why it doubled, okay? So look at here. Standard deviation of the new list. How that related to standard deviation of the old list, okay? Before we go any further, let me remind you. If you add a constant, right? If you add a constant to a list, either they shift the same amount of constant to the right or to the left. The relative position among those entries in the list will stay unchanged. So displacement, this adding constant will not change what? The spread. What will change the spread? Only the multiplier, okay? So standard deviation W, how that related to standard deviation U? As I mentioned, It has nothing to do with what? Displacement. It only relates to the multiplier A. Okay? But what do you know about standard deviation? Standard deviation measures the average distance to the center. And distance to the center is a positive number. Okay? Cannot be negative. So if you times a negative number, say -3, -3, and this is a positive number, what happened to standard deviation W? The standard deviation W will become negative. And that's not true, because standard deviation W also measures what? The average distance to the center in the new list. So it cannot be negative. So prevent this from happening, we put an absolute value. Okay? And this tells us how the standard deviation of the new list related to the standard deviation of old list. Well, it's at the multiplier, you take absolute value times to what? Standard deviation U. And this gives you what? Standard deviation of W. Okay? If you want to copy, property 3. Okay, we're going to use the concept just explained to tell the reason why R is invariant under linear transformation if the multiplier is positive. Okay? The degree of dependence between variable X and Y does not depend on the scale on which the variables are expressed. Now, let's look at the following 6 tables here. Let's work on this one by one. First, let's begin with this one, okay? This is X1, Y1, X2, Y2, X3, Y3. The size of the data is only 3, a very simple data set. You can use the formula to compute its what? Correlation coefficient. Okay? Now, this is not the point. This is actually very easy calculation. You can find average X, average Y, standard deviation X, standard deviation very quickly, and find this number is positive 0.866. Okay? Now, this is now our interest. To find this number is positive 0.866, we simply follow the formula. Okay? Our interest lie on here. Look at the second table. X 244, Y 123. What is the relationship between table 2 and table 1? You can see. What I used to call X, now I call it Y. What I used to call Y, now I call it X. Okay? That is to say I have X and Y column swap, or I rename my X and Y. Look at the formula. Okay? Look at this formula here. Whenever you see X, you replace by Y, and whenever you see Y, you replace by X. What happened? Well, you know multiplication is what? Commutative. If you change the order, it won't affect what? The outcome. Say 2 times 3 is equal to what? 3 times 2. Okay? So you rename X and Y will not change what? The strength and direction of the linear relationship. So this one is still positive 0.866. This is trivial. Okay? Now, look at from second table to the third table. Okay? We find X column remain the same. But what happened to Y column? If I call this is what? Y old. And I call this is Y new. How Y new related to Y old? Let me write it down. Y new is Y old plus 3. And Y old, it means what? 1 times Y old. So this is a linear transformation. From Y new, from Y old to Y new is actually a linear transformation. The multiplier A is 1. The displacement V is 3. Okay? This is a linear transformation. From Y old to Y new. So let's check this formula. Okay? Let's check this formula. Since X column remain unchanged, so this term will not change. We don't need to check it, but we do need to check this one. because we make a linear transformation on y. Let's see what's the impact if we make a linear transformation on y. Y new subtract by average y new divided by standard deviation y new. Okay? Y new, how that related to y old? Follow the linear transformation. Y new is y old plus 3. Average y new. Remember, this is a new center. How new center related to the old center? Follow the same linear transformation. So we subtract average of y old plus what? 3. Okay? Follow the same linear transformation. Remember, linear transformation transfer from old center to the new center. Okay? And then next one, we talk about standard deviation. Okay? The new list, it's spread to the center. How that related to the old list is spread to the center? Depends on the multiplier. Multiplier is 1, that means spread remain unchanged. Now look at here, 3 is a common factor after cancellation. It's y old minus average y old divided by standard deviation y old. No change. So this is still positive 0.866, okay? Okay, let's look at from table 3 to table 4, okay? Let's look at here. The y column, 456, y column, 456. So this column remain unchanged, okay? X column, 244, X column, 488. How these two tables are related to each other? We know y remain unchanged, but x has been changed. What is the change? If I call this is x old, this is x new. Let's see how x new relates to what? X old is x old what? Times 2, okay? X old times 2. So this is a linear transformation, okay? Times what's multiplier? Multiplier is 2. What's the displacement? Displacement is 0, okay? So let's look at this calculation formula again, okay? This time, y remain the same. Nothing changed on this term, okay? But this term changed. So we do need to check this place, okay? Check this expression here. So let's see, okay? Let's see. X new, subtract by average x new, divided by standard deviation x new. Now, how x new related to x old is 2 times x old. Subtract by average x new. Linear transformation transfer from old center to new center. So follow the same linear transformation. 2 times what? Average x old. And now, how the spread of the new list related to the spread of the old list? New list to old list. The spread has been what? Double, because 2 times 2. Okay? Now 2 is a common factor. After you make the cancellation on the common factor, what do we have? We have x old minus average x old divided by standard deviation x old. No change. So this table is still positive what? 0.866. No change. Okay? Nothing changed. Still positive what? 0.866. Okay? No change. So this tells us one thing. Okay? Oh no, let me finish this one first. Okay? Look at from this table to this table. X column remain the same, but Y column I change the sign. Okay? Now, before smallest x related to smallest y. Largest x related to largest y. You know this is positive association. But after you put a minus sign now, the direction has been reversed. This is the Smallest one now relates to what? The largest y. And largest x related to smallest y. Direction has been reversed. So it's minus 0.866. Okay? Now, from this table to this table, y coordinate stay the same. X coordinate I change the sign. Okay? So direction change again. But it's back to what? Positive 0.866. Okay? A group of eight people, their weight and height are recorded. First time, we record their height using centimeter. Weight use what? Kilograms. Second time, the same eight people. Weight measured by the height measured by inches and weight measured by pounds. And look at here, we all know 1 inch is 2.54 centimeters. 1 kilogram is 2.2 pounds. So look at here. From here to here is a linear transformation. From here to here is also linear transformation. So if we calculate the number, this is called R1, this is R2. Since from here to here is just linear transformation, what can you expect on R1 and R2? They should be the same. Okay, they should be the same. So let's come back to see this. Okay, let's come back to see the table. From this one to this one, we change what? We change y. From this one to this one, we change what? We change x. But think about from here to here. Okay? From here to here, we change x and we change y simultaneously. But since the change is just what? Both are what? Linear transformation. So R stay the same. Okay? So come back to see this. A group of 8 people. You measure first time by centimeter and by kilogram, and second time by inches and pounds. Since this is just the change, the difference between what? Linear transformation. So R1, R2 will be what? Stay the same, okay? R1, R2 will remain the same, no change.